Hi everyone, this is Miss Trapp and welcome to our video 113 where we're going to be talking about domain and range. In this lesson, we are going to look at more functions, this time thinking about what input and output values are possible. You will also learn about additional tools on your graphing calculator that allow you to see a complete graph. We'll also be talking about Desmos. As you work with your team, remember to ask the questions. So what values are possible? Can we see the complete graph? And what other information can we use to describe the function? So before we begin, let's start with a warm-up problem. If I gave you the function f of x is equal to 1/2 x minus 4, and I said find f of 10. What is it that we would do? So to find f of 10, we are going to take that 10 and plug it in for x to solve. So the way we write that is by saying f of 10 is equal to 1/2 times 10 minus 4. What you're going to do next is solve just 1/2 times 10 minus 4. A slightly common mistake is students will think that they need to do something with this f of 10. You don't. That's just saying that we plugged 10 in for our variable. All right, so we're going to take 1/2 times 10 minus 4, and if you're not sure, you can always just take 1/2 10 in your calculator, and that gives me the answer 1. Okay, so let's move on to the next one. We've got 1-26 is the next problem, and it talks a little bit about the problem we did 1-2 in a previous lesson. So to just get to the main point here, we have these different functions. We have f of x is equal to the square root of x, g of x is equal to negative x minus 2 squared, h of x is equal to 2 to the x power minus 7, and k of x is equal to negative x over 2 minus 1. So we've got a character here named Jared, and Jared puts an input of 6 into this function, and he gets an output of negative 16. Okay, well now he's saying, okay, well let's take the negative 16 and go with this function, f of x is equal to the square root of x, as his next function to use. But he's worried that there might be a problem if we're going to use negative 16 as an input, and it's asking us here, is there a problem, and explain. So what that is saying, just to write it out for us, we have the function f of x is equal to the square root of x. And Jared is asking, well, can I take negative 16 and plug that in for our x value? And like this is where he's wondering, is there a problem? So let's think about that for a second. A square root is a number, is like undoing a squared. So the square root of 16 is 4 because 4 times 4 is 16. Well, is there something times itself that gives us negative 16? So let's think about that. If we've got 4 times 4, well, that's positive 16, so that can't work. If we had negative 4 times negative 4, well, that's still positive 16, so that's not going to work either. Well, now I'm just confused. I don't know what the square root of negative 16 is, so I'm going to try my calculator. Oh, interesting. So now that's an error. So what we're talking about here now is that we actually cannot take the square root of a negative number. So to answer the question here, is there a problem, and explain? Well, yes, there is a problem actually, because negative 16 has no real number square roots. And just a little side note, you cannot take the square root of a negative number. Well, that's a little messy, so I'll fix that. Negative number. Okay, so Let's go to the next part here, part B, and it says, because it's not possible to take the square root of negative 16, it can be said that negative 16 is not in the domain of the function f of x. So f of x is equal to the square root of x. The domain of a function is the collection of numbers that are possible inputs for that function. Find two other numbers that are not part of the domain of f of x, then describe the domain. In other words, what are all of the numbers that can be used for the inputs? So I'm going to break up this question just a little bit. So let's go back here. We've got f of x is equal to the square root of x. And what it's asking are what are all of the possible inputs we could put in to a table, graph, whatever, for this function. So we already said we can't use negative 16. That's not going to work. But we're wondering, well, what numbers can we use? So let's take a look at Desmos for a second here. If I said y equals the square root of x. Okay, so this is interesting. My very first point is 0, 0. Notice there's nothing else to the left of this, right? So when we're thinking about just looking at our x-axis here for our domain, which numbers are we using? Well, we're only using numbers that start at 0 and then up from there. So notice all of these numbers, are any of them negative? No, these are all positive numbers. So that tells us a lot about our domain and our range, but right now we're just talking about the domain. So we can start with 0 just like it did and go up with any positive numbers from there. So the way we're going to write that is we're going to say for the domain, the domain, so let's describe it, is all positive numbers and 0. And there is a little bit of a fancier way to write this. So I'm going to write it as an inequality by saying x is greater than or equal to 0. So now it's not asking us right now to talk about the range, but let's talk about the range. Let's just describe it here. So the range is what? Which numbers could we put here on the graph? So if we go back to Desmos, notice that our range values are also all positive numbers and or 0. So just to describe it, I'm going to say the range is all positive numbers and 0. All right, great. So let's go to the next one. We're going to skip down to 1-27. And this problem is asking us to use our graphing calculator to help us draw a complete graph of y is equal to x plus 1 times x minus 9. So it wants us to draw the graph and then talk about some window settings, but I'm actually not going to do that for right now. I just want us to draw the graph. If you have not used your graphing calculator yet, you can. Or you can also type this into Desmos. So when I go to my graphing calculator, there is the button right up here that says y equals. So I'm going to click that, and then I'm going to type in x plus 1, x minus 9. And now, if you just look up here on this line on your graphing calculator, you'll also see a button that says graph. So I'm going to graph it. I'm going to adjust here a little bit. Okay, so it wants us to describe the graph completely. Well, I see that it is a parabola, so that's fun. And then it also wants us to describe it completely. So let's think about more things about it. Well, if you remember about parabolas, we do have something called a vertex. So the vertex is like either the max or min point. So it could be here or here depending on how it's shaped. So in this case, we do have a vertex. It's the very bottom point. Ooh, and that's right there, the minimum. So we've got vertex at, it looks like 4, negative 25. And what else? Do we have a y-intercept right there? So we have a y-intercept at 0, -9. And we also have two x-intercepts at -1, 0, and 9, 0. So let's write those down. We've got a vertex x-intercepts. We've got -1, 0, and 9, 0. And we have a y-intercept at 0, -9. So, I mean, maybe there's more things we could talk about, but I think that's fine. I'm pretty happy with that description. And we will talk more about window settings and relation to domain and range at some point, but just not right now. All right, so now let's go to that next page. So you should be on page 14 in your packet here. So here's what I wrote down for your important ideas. And you can go ahead and pause the video and write these. I've just got some vocab words and really just focusing on how domain and the function and range relate to each other. And at the bottom, I wrote a function relates each element of a set with exactly one element of another set and drew a picture. So go ahead and pause the video and you can write that down. On this page, this is on page 15, it just wants us to read. So it says the domain and range is the set of possible values for the input of a function, so that's the domain. And this set consists of every input value of x for which the function is defined. The range of a function is the set of possible values of the output. This set contains every y value that function can generate. So domain and range are often written with an inequality notation as shown in the examples below. And we kind of did that a little bit ago. Don't forget we also have these symbols here. Those are positive and negative infinity. They mean that the domain goes on and on without ending in the positive or negative direction. Infinity is not a number, it's a concept. So let's look at these examples here really quick. So it says if I were to tell you that you have a domain and it's any number between and including -2 and 7. So that means our x values are anywhere between -2 and 7. The way we would write that with an inequality is here. So this is telling me when you see something like this, that it's between -2 and 7, and because of that equal sign symbol, that means it could also be -2 or 7. If the range is any number greater than, but excluding 4, so it's greater than 4, but it can't be 4. So we could write it like this, y is greater than 4. If the domain is all numbers except for -3, then we could say x is not equal to -3. And if the domain is all real numbers, then we could use -infinity to positive infinity. All right, next page is the check your understanding for page 16. We're going to look at 1-29. So it says we're going to reverse our thinking here a little bit. So it says sketch a function that has a domain of all real numbers between and including -3 and 10. So this is how we would write it with inequality. And a range of all real numbers between and including -4 and 6. That's how we'd write that. And notice the x and the y for the differences between the domain and range. We don't have to write an equation, but we want to be as creative as we can be here. So don't freak out because this isn't as bad as you think it is. So let's just start back up here. We've got, let's see here. We've got a domain and it's between and including -3 and 10. So that's talking about my x values. So I'm going to write 1, 2, 3 for -3, and then I'm going to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay, okay. So now let's take a look at the next part, which is our y values or our range written from -4, including and between -4 and 6. So I'm going to count down 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So now it just wants us to draw. So let's think about that a little bit. We need to get some points. Well, I know that I could have a point -3, 6, because it like when we're looking at this, it has to be anywhere basically in this box now. So we can make a function really anywhere, but it has to be in between these restrictions, right? So I don't know. I mean, I know I've got a point that could be here, -3, 6. Like that's in my restriction. And I guess I could have another point even, I guess at like 10, 6. I could do that. And let's just draw, I don't know, let's just draw a little function. Oops, sorry. Let's just draw something here. Here, I mean, we've got something. It's not perfect. I mean, I could even just do something like this. But it all works, so it's whatever works for you. I mean, obviously some things won't work. I shouldn't say that. But, you know, we've got a function here, and we met our restrictions, so we're all good. Now let's go to 1-30. This one wants us to look at a graphing calculator. I know we've mostly been using Desmos, but I'll go ahead and kind of switch back and forth. So how can a graphing calculator help you find the solution to a system of equations? Consider this system. So we've got 5x minus y equals 35 and 3x plus y equals negative 3. Well, let's think about that just for a second on what is a system of equations. So a system of equations is two or more equations that share variables. Okay, so it says first graph the system in a standard window. Can you see the solution on your screen? Well, it is asking us to use our graphing calculator. The problem with that though is if I go to the screen, notice how it says up here, y equals. So I need it to be in that form. So what I'm gonna do first is make each of these equal, like be a y equals form. So I've got 5x minus y equals 35. So make my t. I'm going to subtract 5x on each side. So I've got negative y equals negative 5x plus 35. Then I'm going to divide by negative 1 because we want what y equals, not negative y. So y is equal to positive 5x minus 35. All right, so I got that. It's a y equals. Awesome. Now let's do, we've got 3x plus y equals negative 3. So I'm going to make a t here, and I'm going to subtract 3x. So that makes this y equals negative 3x minus 3. All right, so let's go back here. It says first graph the system. So I'm going to go ahead and do that. I'm going to graph 5x minus 35 and negative 3x minus 3. I'm going to click graph. Okay, so it says, can you see the solution? So if you had to take one guess, like what do you think the solution would be? If you think the solution would be the point where they intersect, which is right here, 4, negative 15, you were correct. Yes, we can, because it's the intersection. All right. So it says also, like in Desmos, you can adjust the viewing window, and we can adjust the window in our graphing calculator as well. So we'll talk about that later, but it does want us to graph or draw a quick sketch of this, of our screen below. So whether you use Desmos, if you went in and typed it there, or you tried out your graphing calculator on your Chromebook, awesome. But it does want us to do a sketch. So remember, a sketch is not perfection, but we want it to be somewhat accurate. So I'm gonna go ahead and draw my X and Y axis here. And let's start thinking about some clues, okay? So I know that the solution was 4, negative 15. So I'm gonna count 1, 2, 3, 4. I'm not about to count down to negative 15, so I'm just gonna put that right there at the bottom, okay? So I'm gonna put a point here, and we know that that's where they're intersecting. So let's go back here and find out another point for this line. I see that this one has an intersection at 7, 0. So I'm at 4, 5, 6, 7. So I'm going to put a point right here, and then I'm just going to do a little sketch of this line. Not perfect, but I'm okay with it. Then the other one, we've got an intersection at negative 1, 0. So that's right here, and I'm going to go ahead and draw a sketch like that. All right, so we used the trace function to find our solution, or you just clicked using Desmos. And it says solve the system algebraically. So we've done this before in nonlinear algebra, but it's probably been a while. One of the methods is called substitution. Okay, so that's what we're gonna do. So let's think back to our original problem here. We had 5x minus y equals 35 and 3x plus y equals negative 3. And so what it's asking us to do using algebra, and not thinking that we already, and forgetting that we know the answer for a second, what number could I plug in for x and which number could I plug in for y that would make both of these true? Well, we already know it's 4 and negative 15. If I plugged a 4 in and a negative 15 in, these would both be true. But how could we do that with algebra? And substitution is one of the methods for that. So what I'm going to do is I'm going to try to get one of the variables by itself. The one that stands out to me is this y, because what I can do here pretty easily is isolate that y. So I'm going to subtract 3x on each side like I did before. And now this is y equals negative 3x minus 3. So what this tells me is that because y is equal to negative 3x minus 3, I can go ahead and plug that in for this y. Right, so let's go back to this original one here. So we have 5x minus y equals 35. And I'm going to go ahead and plug in negative 3x minus 3. Right, so there we go. Before I do anything, I'm going to distribute that negative. So we've got 5x plus 3x plus 3 equals 35. Combine like terms, so that's 8x plus 3 equals 35. Subtract 3 on each side, so that's 8x is equal to 32. Divide by 8, so x is 4. Awesome. And isn't that what our answer was up here? Yes, it was. So now let's see if we can get negative 15 algebraically. So let's go ahead and plug in that 4 back into y equals negative 3x minus 3. So I'm going to plug that in, y equals negative 3 times 4 minus 3. So I took this 4, plugged it in here, and that came from over here. Now y is equal to negative 12 minus 3, which is negative 15. We did it, solving algebra. And it says, well, let's discuss those two methods and explain which one you prefer. So that's kind of up to you, right? We solved using graphing, and we found the intersection. And we solved using algebra, and we used the substitution method. So it says, which one do you prefer? So we don't have a team right now. So which one do you prefer? Write that down. What do you think? What was a little easier for you to follow? And then the last piece here is you do have your learning logs throughout. This is where we're asking you to reflect on your understanding of what we just learned. So what you want to do is label. So we've got the domain and range, and we've got to write down the date, and then just write down some things you learned. What did you learn? What do you still have questions about? And this could be great too. After you write about what you've learned, did you have any questions about anything so you can remember, so you can ask your teacher? All right, well, thanks everyone for watching, and have a great day.